Our next lesson is going to be about rewriting equations and formulas. So first of all, if you look on page 26 of your book, there is a nice little box that has some important formulas that you may or may not know. So the only one I really want you to have memorized is D equals RT. That's the main one you're going to need right now. There's a bunch of others that you probably learned in geometry. So let's go ahead and do an example with D equals RT. There's going to be two things I'm going to ask you to do in problem number one. The first thing I'm going to ask you to do is solve D equals RT for T. Then you're going to find the time it takes to travel 312 miles at an average rate of 48 miles per hour. So I'm actually going to break this into part A and part B. And on your quiz or test for this chapter, I'm going to actually list them like that, A and B. So the first part, you're solving D equals RT for T. What that means is I need to get T by itself. So remember that this RT means R times T. So what I'm going to do is I'm going to divide both sides by R. I don't yet know what D and R, actually what the values of those two are. So I'm actually, when I solve for T, I'm just going to rewrite it like this. You can write it with the T first if you want to. I get T equals D over R. So that's part A of the problem. Part B, now we're going to actually use the values that they give us. So they give us that we're trying to find the time. Time is my T, so I don't know that. We also know that our distance is 312 miles. And we know that our rate is 48 miles per hour. And one thing you might notice is that your time is going to be in hours. The way that we know that is because our R mentions hours. So now what you're going to do is you're going to take the formula that you just solved and you're going to substitute in D equals 312 and you're going to also substitute in R equals 48. In the end, you will find that your T is 6.5, and once again, that's going to be in hours. So for this problem, feel free to abbreviate as you're writing it out. It's really, really long. So I'm first of all going to ask you to solve the formula A equals 1/2 B1 plus B2 times H for B2. That's going to be the first thing I ask you to do. The second thing I ask you to do is find the length of one of the bases of the trapezoid, and I gave you the length of the other base, and I also gave you the height and the area. So let's do part A first. And actually, feel free to pause this and either use the pause time to finish writing down the problem, or actually what I would prefer is that you pause this and try the problem on your own. So we're going to start with A equals 1/2 times B1 plus B2 times H. We would like to solve this for B2, which is this one right here. There are several ways that you can do this type of problem. The main idea in this, though, is that you need to get that B2 by itself. And you do that by moving over everything else that's on the same side of the equal sign as that. So I would generally say start with whatever's furthest away from the B2. In actuality, you have two choices. You can either start by getting rid of the 1/2, or you can start by getting rid of the H. I am going to go for the 1/2 because having a random fraction makes the problem a lot harder. So you can do that by multiplying the right-hand side by 2 over 1, which is the reciprocal of 1/2. When you do that, you'll find that the 2's are going to cancel out. Also, you are not allowed to just multiply by random 2 over 1's. You have to do the same thing to the other side, multiply by 2 over 1, and that's actually going to give you 2a. On the right-hand side, since everything was already multiplied together, like that stuff in the parentheses was multiplied by the h, and that whole thing was multiplied by 1/2, you do not need to do anything else. You do not need to multiply anything else. So then I now have this. From there, my next step is to get rid of that h. I'm going to do that by dividing both sides by h. So once I do that, I'm going to get 2a over h equals b1 plus b2. The last step on this is to move over the b1. And when I do that, my final answer is going to be 2a over h minus b1 equals b2. Or if you want to write it with the b2 first, you're going to get b2 equals 2a over h minus b1. This is a tricky problem. We'll do a few more examples with this. To be honest, the one that you have on your test on this is not going to be as complicated as this, but if you can do this one, you can do anything. So then we come to part B, and I'm actually telling you a few things. I want to find the length of the second base. I know that the length of the first base, which is my B1, is 13 centimeters. I know that the height is 10 centimeters. And I know that the area is 105 square centimeters. The way that you solve this one out is by substituting these things into the equation that you have up there. And actually, once you have this, it's not too hard. You just need to simplify it out using the order of operations. And you're going to end up getting 210 over 10 minus 13, which is going to give you 21 minus 13. So your final answer is going to be 8. And once again, we used centimeters before, so you'll find that it's 8 centimeters. So here we have a similar problem to the previous ones. If you feel like you know what to do, feel free to try it on your own. I'm going to call this part A, part B. So once again, if you know what to do, you can pause and try it on your own. So for part A, we have 5x plus 3y equals 8. We want to solve this for y. You do that by moving over the 5x, and that gives you 3y equals 8 minus 5x. The next thing that you're going to do is you have to get rid of the 3 that's with the y. So you do that by dividing everything by 3. The reason we do that is because this is 3 times y. When we do that, we get y equals 8 over 3 minus, you can either write it as 5x over 3, or you can write it as 5 over 3x. I'll actually write both answers out. Whichever method works better for you is fine with me. So I'm going to use the one on the right, but if you wrote it the other way that I have on the left, that's also fine. So then my next part of the problem, I want to find the value of y when x equals negative 5. So I'm going to substitute negative 5 in for that x. And there's a few ways to deal with these fractions. I believe, in my opinion, the easiest way to do it is to write it as negative 5 over 1 and multiply it across. That gives you y equals 8 over 3 plus 25 over 3. So from there, you keep the denominator the same, you add your numerators. That gives you 33 over 3. Remember, 33 over 3 you divide, which gives you 33 divided by 3 gives you 11, and that's your answer for that one. Our last problem here is the most challenging out of all of them. We are going to solve this one for y. I'm going to call that part A. The second part, I am going to ask you to find y when x is 3. So let's start with A. The reason that this one is so challenging, you'll notice, is because we have 2 things in there for y. We have 2 y's. So the best way to do this is to pull the y out front. We say we factor out the y. You can think of it as the reverse of the distributive property. Then everything left over is going to go in these parentheses. So we're going to be left with 2x minus 5 and then equals 8. If you would like to go backwards and distribute the y, you would find that you would get what you started with. So from here, we need to move over the 2x minus 5. We do that by dividing this entire thing. We do that on both sides. We divide both sides by this entire thing. So on the left-hand side, that entire thing cancels out, and we're just left with a y. The right-hand side, we are left with 8 over 2x minus 5, and we have y equals something, so we're actually done. Then part B, we are going to find y when x is 3, which means I get y equals 8 over 2 times 3 minus 5. That gives me 8 over 6 minus 5, which gives me 8 over 1. So my answer for that is 8.